Now we shall continue. Now we'll talk of properties of matrix addition. Properties of matrix addition. First property is commutative law. Commutative law holds good for any two matrices being added. Supposing first matrix being M1 plus M2 can also be added in the form M2 plus M1. This is stated according to the commutative law. That is, two matrices over addition follow commutative law. The second is associative law. So in case of associative law, two matrices M1 plus M2 further added with any third matrices is equivalent to addition of first matrix with the sum of second and the third matrix. No matter whether the first two matrices are first added or the last two matrices they are first added, the product would be similar in both the cases. Therefore, the associative law holds good in matrix addition. Third is additive identity. Additive identity. So whenever a matrix is added over a null matrix, or you can say a null matrix is added over any matrix, then resulting matrix would be that particular matrix only which is being added with the null matrix. That is, M1 plus null matrix or null matrix plus M1 would give rise to M1 only. And this is the additive identity. Next is additive inverse. Now what do you mean by additive inverse? Suppose any matrix is M1. So additive inverse of this matrix is negative times M1. So we need to change the sign of the given matrix, and that is said to be additive inverse of that matrix. That's all for the properties of matrix addition. Moving on further, we have multiplication of two matrices. Two matrices. Suppose first matrix is of order 2 by 2 and the second matrix is again of order 2 by 2. Now remember, in case of multiplication of two matrices, the first matrix with a row number m and column number n, and second matrix must contain the row number equal to the column number of the first matrix, that is n, and the number of columns of the second matrix, that can be anything. So the number of columns of the first matrix must be equivalent to number of rows of the second matrix for any multiplication of two matrices to be done. So for multiplication, the number of columns of the first matrix and the number of rows of the second matrix must be equal. So the resulting matrix, suppose this matrix contains dots. So it contains row 1, row 2. Second one has column 1 and column 2. So how multiplication possible? Row 1 into C1, that is R1 C1, is the first element of the resulting matrix of order 2 by 2. Row 2 into C1, row 1 into C2, and row 1 into C2. So this is the resulting matrix after the multiplication of these two matrices. Now, for matrices having orders like M cross N and N cross P and are being multiplied, then the resulting matrix will have the order M cross P. That is the common element, that is the number of columns for the first matrix and the number of rows for the second matrix. They get cancelled and the resulting matrix have the order M ratio P or M cross P. Now, it is a different thing to say that we are multiplying a matrix of order M ratio M cross N and with the matrix of N cross P. Then if I multiply N cross P with m cross n. That couldn't be possible, as it violates our condition that number of columns for the first matrix must be equals to number of rows of the second matrix. So it doesn't satisfy our condition, so the result is invalid for us in this operation. But the result is quite valid for us in this operation. So the multiplication of any two matrices that doesn't allow or hold good the commutative law. Now we'll talk of properties of multiplication. Matrix multiplication. First, it is anti-commutative. That we have seen now only, that it is anti-commutative in nature. That is, A cross B can never be equivalent to B cross A. Second is associative law. So for this, associative law holds good. That is, A multiplied by B multiplied by C is equals to A multiplied by B multiplied by C. Third is multiplicative identity. Now what is multiplicative identity? That is, whenever I is the symbol denoted for any identity matrix, and whenever an identity matrix is multiplied by any matrix, or any matrix is multiplied by the identity matrix, then the result would be that matrix only which is being multiplied with the identity matrix. This is said by the multiplicative identity. We shall continue with the rest of the chapter in the next clipping.